Welcome. This is ASA 101, how to take a Cisco ASA firewall directly out of the box. We're assuming that the device is brand new, or if in fact it does have configurations on it, how to wipe it and start fresh. We're going to go through the basic steps to get it communicating on the network. We've got probably 5 or 6 steps to do that. It's actually pretty simple. We're going to assume that you have basic networking knowledge and that you're either doing this in a work environment or you're doing this in a lab at home, that you want to get familiar with the basic commands of setting up an ASA. So we'll go ahead and take a look at the different devices that are in the ASA line. The top device is an ASA 5505, typically used in small offices. It has certain capabilities that are perfect. It'll support up to 10 users. It'll support VPN or virtual private networking. It's very inexpensive and it's robust. Like I said, it's good for small offices. As you go down the product line, you see other devices that are a little bit bigger, a little bit more capabilities, a little bit more expensive. But typically, to get them up and functioning and running out of the box, it's fairly straightforward. We'll get to that. Today we're using a 5510, which is a device that is the second one down here, this chassis here. To give you an idea of the commands we're going to go use, we're going to enter all these. We'll go through these one at a time and explain exactly what they do. And we're going to break the device so we can get a little bit of troubleshooting in and work out things that might not be working straight out of the box. Our network is pretty basic. We've got the internet coming in. We're tying that to the outside interface on the ASA. There's 4 ports on this particular one. You can assign the ports as you wish. Any port can be outside, any port can be inside. And you have 2 additional ports, which we're not going to feature currently in this configuration. We're starting with a internet connection, an Ethernet connection to the device, but since the device is not currently configured, that's basically it's not functional. To put in the initial configuration of the device, you're going to need a serial cable, and that's going to be a Cisco blue cable. It's flat. Typically, they use a RJ45 on one end and a DB9 serial connector on the other. We're using a USB to serial converter so that we can use this cable. Newer models of the ASA plug in directly with a USB cable, but typically the ones that you'll see out there, especially the legacy ones, they're all a serial. So we do have a serial to USB converter. This device was just completely wiped and it's booted up. This is what you see if you have a serial cable connected to it during the boot up process. And some of the things that it'll prompt you to do is to put through a interactive pre-configuration on the firewall. We're not going to do that because it's kind of clumsy. The command prompt that you'll see typically is Cisco ASA. We're going to do a enable EN, and there's no password out of the box, and you see that there's a pound sign at the end of the prompt now. We're going to do a show run. And we've got 4 interfaces. None of them are assigned with any configurations currently. There's very little in here to start. Pretty straightforward. First thing we're going to do is we're going to configure the outside interface so it talks to the internet, and the internet is the address is provided by our internet modem. And we're going to use that now. Typically, you wouldn't. You'd want to tie your ASA to a public address, but for this purposes, we're just going to use the address that's going to be assigned to the ASA from the internet router that we have. And just for today's experiment. So we're going to go into configuration mode, which is config T, which T is short for terminal. And we don't want to do any anonymous error reporting, so we're going to say no. And the first thing we want to do is change the configuration on our 00 gigabit interface. If you look at the configuration right there, 00, Cisco has unique numbering. There's 4 ports. They are 00, 1, 2, and 3 instead of 1, 2, 3, and 4. We're going to turn off the shutdown. We're going to give it an interface name IF. The security level will auto assign, and we're going to give it DHCP for its address. So let's start there. Interface GO/O. Name if outside, which is a standard name. You'll be using standard names for most of your interfaces. Outside is typically the interface facing your internet. Inside is typically the interface facing the computers in your office or your labs, what have you. You can also use different names such as DMZ and so forth. But for this experiment, we're going to use outside for one of the interfaces and inside for the other. For this, we're going to give it an IP address of DHCP, and that will automatically assign an address from the ISP modem that we have here. And we're going to do a no shut on it, which basically turns the device, that port on. Get out of interface configuration mode, and we'll show int IP brief. That's interface IP and brief BR. And if you look, it's automatically assigned itself an address from the internet. We'll just get back into config T. We're using number 3 for the inside interface. Inside will be the name for that. IP address 192.168.80.1. Okay, and we're not going to unshut that just currently. We're going to go ahead and set up DHCP for any devices that plug into the inside interface. Will be issued its own IP address directly from the ASA. In order to do that, let's try this. Get out of this and go back into config T. And it's DHCP address 168.80.2. We can't use 1 because that's being used by the inside interface. And we're going to make that range to 55. We need to make that on the inside. And go ahead and take that. We're going to do a DHCP enable inside. That'll turn on that DHCP server. One other thing we're going to need to do is go DHCP DNS, and we're going to assign a DNS for our inside clients to use so they'll be able to surf the internet. Now currently, let's go back and show IP int brief. Show int IP brief. And you'll see that we have 3 has got an assigned address. It's down because currently nothing is plugged in. It's down because right now we have that interface shut down. So if we do a show run, we see that interface 03 still has the shutdown in there. The reason I wanted to do that is because when I wanted to turn it on, I wanted to make sure the DHCP was enabled and DNS was enabled, so our PC that's plugged into port 3 will draw those addresses. Interface G03, no shut, and that turns it on. In a minute here, we should get a comment from our PC telling us that that port is now available. Let's check out our PC and see if it has an address. And it does not. So let's do a renew. And see, and there it picked up 80.2, which is good. IP config/all, and we can see that we also have DNS. So the ASA has issued this PC its address and its DNS routing. That being the case, now we should be able to use our PC to access the ASA through an Ethernet connection. Now we're using secure CRT right now, and we already have a session over here that is looking to talk to that device on 80.1, which is the port, the inside port. And if you look, it's not connecting. So let's go back to our serial port connection to this and find out why. First of all, you have to tell the machine who you are and are you allowed to talk to it. So let's put those lines in here, the configuration. Config T. And we're going to do SSH00 inside, which will allow SSH clients to talk to the device from the inside interface, which is 0/3. We also now have to tell the machine who it is. So we're going to do username, spell here, Cisco password, Cisco privilege 15. That'll give us full access to all the different commands inside the box with this username command. Now let's go back and try to get back to the device now. And it's asking username and password, which is a good thing, but it failed. Why? Because we have a username and password, but we don't have authentication to do that. The machine knows who we are, but it doesn't know that we're authorized or not. A way to get that to work is you have to tell the machine to go ahead and use the local database inside the ASA, which we created a username and password, to use that to authenticate to the ASA for access. And the command to do that is AAA, let's see here, it's authentication, and don't mistake that for authorization. We want to do authentication, SSH, console, local, and local has to be in caps. And what that's telling it is we're using the local database, we're allowing SSH on a console connection, which will be through your Ethernet connection. Let's go back to the Ethernet connection and try to access again. And bing, we're in. So now we're in we're talking to it not on the serial, but on the Ethernet connection, which you're going to want to do eventually, because in order to access the machine remotely, you're not going to be able to do that with a serial connection. You want to do it through your Ethernet, either through your WAN connection or your outside connection or your inside connection. I don't recommend doing direct access to an ASA through the outside connection, especially with Telnet. I'm using SSH. You want to use SSH and you want to access it through the inside connection, typically through a VPN. We're not going to get into that currently today, but right now you can see that we do have access to the machine. Get back into the enable prompt, and there's still no password for enable, so we're going to do enable password. I've got to get it. T, enable password, Cisco, which obviously you don't want to use that. Now we're going to go ahead and give you a little bit of a cheat sheet on some commands that we use quite often. We do a show run, we show IP interface brief, and we use config T. But those are a lot of words to type every time, and if you're not a very good typist, you're gonna mess up like I've been doing. So let's create some shortcuts for that. So it's the way to do that is command alias, exec executable prompt, SI show int IP brief. Let's make another one. Command alias exec sr show run. Command alias exec ct config t. Now we have 3 different shortcuts, and let's go back here. Let's try them. So we can do a SR for show run, and there you go. And whenever you're scrolling through that, if you want to break out of the different prompts, just hit Q, and it'll take you back to your normal prompt. Let's do an SI, and there's the interfaces. You can see everything's up. That's the first part. Now what we want to do is we have a PC that's connected to the ASA. The PC has got its address. The ASA is talking to the internet. And let's prove that. Let's do a ping. And there's no route to the internet. That's one of the things that's broken that we have to fix. So we have to put in a route. So we're going to do route 00, which means anything you're trying to get to. We're going to assign the next hop 192.168.1.1, which is the address of the internet service provider's router. It's on the same subnet as the outside interface, which I've got tied to 0/0, and I just happen to know that it's 1.1, and we're going to say outside IP route 192.168.1.1 outside. What's going on here? Route outside 0.192.168.1.1. There we go. Get the syntax correct. Now if we do a ping, we have success. That part is done. Now let's go back to our PC and bring up a command prompt on the PC. And we'll do a ping 192.168.80.1. That's the inside interface, and we're connected to that. Let's do a ping 192.168.1.132. That's the outside interface, and you're not going to work. It's not going to work being able to do that. What you're trying to do is you're trying to ping through the firewall, and from an initial configuration, it's going to inhibit that. We'll get back to that in a little bit. But let's try this. Let's try to ping yahoo.com. And it has no idea how to do that. Right? That's another thing that's broken, and we're going to fix that now. In order to get the machine to pass traffic through it, you have to create a NAT, a network address. The ASA doesn't do that typically right out of the box, so we're going to go ahead and do that right now. And we're already in config T. We're going to say network object inside. And that last one is any name that you want it to be. We're calling it inside because we're referring to the inside subnet. You can call it Joe anything. We're going to do, object network inside. That's the syntax. And we're going to do subnet 192.168.80.80.0. And that's going to tell this object that it's referring to the subnet of the inside. And we're going to do a NAT for that, inside, outside, dynamic interface. And what that does is it'll assign a dynamic port along with the outside IP address to traffic leaving the ASA. You can't actually, without a NAT statement, you'd be trying to communicate to the internet with a private address that we have on the inside interface 192.168.80.1. That just won't work. So we're going to dynamically translate it to the outside interface, which at this particular moment is also a private address. But typically, if you're tying your ASA to the public internet, you'll have a public address on your outside interface. Now that we have that NAT statement, let's go back to our PC and see if we can ping. And there we go. We're able to ping the internet. Still not working. What have we forgotten? Maybe Yahoo's not allowing pings. Still not liking it. Let's take a look at our configuration and find out what we got going wrong here. Let's get out of here. And there's the entire configuration. In order to pass pings, we have to tell the machine to inspect pings. And right out of the box, it doesn't do that natively. So let's get into that. And we're going to do our shortcut CT. And we're going to change this policy map. In order to do that, policy, map, global, policy, which is this line right here. We're going to follow it with class inspection default. Inspect RCMP, which is the protocol used for pings. And that should fix that. Let's go back and try to ping again. Ping 8888. That's working. Ping www.yahoo.com. That's working. And let's get back to our ASA. Exit out of here. And I'm going to edit and clear this, and we'll do a show run SR. What we have our inside interface is DHCP, our outside interface DHCP. Our inside has got a static address. We have created an object for the inside subnet. We have created it. When you do that, it'll also create this NAT line. We've got the route statement in here that tells the traffic where to go for a default route. We have our authentication here that's allowing people to log in locally through the local username database. We have a SSH timeout of 5. If you walk away from this session and it's after 5 minutes, it'll automatically log you off. We have SSH in here allowed from any device on any subnet to allow into the machine on the inside. You can change the SSH timeout from 0 to 60 minutes, I believe, or from 1 minute to 60 minutes. We have the DHCP assigning the DNS address of 8888. You can change that to whatever you like. We have our DHCP server enabled on the inside, assigning this range of addresses to anybody plugging into the inside interface. We have a username Cisco, so that we have a name that we'll use to log into the device. We've inspected ICMP, so it'll allow pings through the device. And that's really about it. If you need a listing of all those commands, it's right here. Pause the video and you can take a look at what we have here. Now, a couple of other things. We did the command aliases, so we have shortcuts. What we're going to do now is we're going to save this configuration with a WR. Now, I don't recommend doing any changes on a firewall that's in a production environment. All the commands that I've just entered in this are destructive, and you will take down your network if you enter them in a device that's currently in use. We've also started with a device that was completely wiped clean when we started, and we now have got a device that will pass traffic. We've already verified that we can ping. Let's try a web browser here. And let's go, well, we've got a Google prompt. Let's go to www.yahoo or YouTube and Bing. We're able to access YouTube. So we are communicating through the firewall. It's able to communicate to the internet. It's passing traffic. We're able to ping. We're able to access the device through a SSH connection. We're using Secure CRT, which is highly recommended. You can also use PuTTY, which is a similar program. It's available for free. CRT has a couple of features built into it that are a little bit more advanced. One thing about Secure CRT that you need to know, sometimes it will not allow you to talk to a Cisco ASA directly out of the box. And how to do that, I've got this session here that's already in Secure CRT to talk to that. In Properties under SSH, if you look down here, it says Diffie-Hellman. Typically, Secure CRT does not use that as a authentication to devices. Let's go ahead and close out of here. I'm going to disconnect both serially and through the SSH connection. And we're going to try to get back into the device one more time. That way turn Diffie-Hellman off. And it says, nope, not going to let you do it. So if you get that error, we're going to go back in here, turn on Diffie-Hellman. Okay, and then it's prompt now it works. CISCO, enable password, CISCO, config T, exit, show run SR, space, SI for the interfaces. That's how to do it. If you have additional questions or if you'd like other features on videos, I'm more than happy to make them. I'll be making these videos about once a week. We'll get into more advanced topics such as VPN, 2 different types, site-to-site VPN, and direct access from, say you wanted to access your network at work from home with your laptop. That's called AnyConnect. We'll be going into that. We'll also be going into several other factors such as access lists, different zones. We'll get more into security. Like I said, if you have any other questions on features that you'd like to see in the Cisco ASA, like, subscribe, and drop me a note in the video down below the video. I'll try to get back to you and look for more videos on the Cisco ASA.